So in this lesson, we're going to take a look at how to simplify radicals, which we've seen before, but this time not all of our radicals will be square roots. They might be a different root, like a cube root or a fourth root, etc. So when you simplify radicals, if it is an odd root, like a cube root, fifth root, etc., they will have one real answer. All odd roots have real answers because you can take a negative times itself 3 times, for example, and get a negative. But you will not get the positive answer, so there's only one answer. With even roots, there's 2 options. You either get 2 real roots, fourth root of 81 is positive 3 and negative 3, or you have 0 real roots if you try to take the square root or an even root of a negative number. You'll get imaginary roots. So here's this chart. I believe we've seen this before, but I think the first time that I had this slide, the first column wasn't there, which was the regular numbers. So some people, I think, were a little bit confused on how to use the chart. So for example, if we are looking for quartics, our 4th power, so if we are looking for the 4th root of 16, we would go back to 2, and so on. So that's how we're going to use this chart. And again, this is in your notes, but for those of you who write your notes paper copy, there's the other part if you want to pause and get these down. All right, so the first thing we're going to do is evaluate perfect roots. And there are no steps on this page because you just have to memorize that chart. So if you don't have the 4th root of 256 memorized just yet, let's jump back to this chart. Again, we're looking for the 4th root. So that'll be the quartics, the one we looked at for our example before. And it was 256, so we follow this back to 4. So the only thing we really have to think about is when we have an even root, there are 2 possible answers, positive and negative 4. Because of course, negative times a negative times a negative times a negative will give you the positive 256. So for 343, we're looking for the cube root. So when we check our chart, perfect cubes, scroll down to 343, follow that over to our answer. The cube root of 343 is 7. And with odd roots, there's only one answer. If it was a negative 7, it would multiply to a negative 343. Next, we're going to take a look at simplifying variables under the radical as well. So our process is, we're going to simplify the numbers, and then we'll look at how to simplify the variables. So remember, when simplifying a number, you find the perfect root, which is going to change depending on which root we're looking for. So we're going to start out with the square root, so we're looking for perfect square factors of 48. If you don't remember, you could do the factor tree. 24 times 2 gives us 48, 12 times 2, 2 times 6, 2 times 3. So if you do the factor tree and you use it this way, you look for pairs because it's a square root. For example, if we had a cube root, we would look for 3 of a kind. So we have a pair here and a pair here. So anytime you have a pair, you can think about this as we have under the radical the square root of 4, because that would be the 2 times 2. So when you take the square root of 4, it comes out as 2. So this pair will come out as a 2 as well. And then this 3 will be left under the radical. And the next one, I will show you a different way to organize your thoughts on that one if that factor tree didn't help you out. For simplifying the variables, you divide the power by the root. So think about it this way. If I were going to do my factor tree on A, I would have A times A times A. Or I could think about this as A squared times A. And when I take the square root of A squared, I get A. So A comes out, and then I'll have this A left under the radical. If I take 3 divided by 2, I have 1. With a remainder of 1, and that remainder is what will go under the radical. So we'll think about that process with B. 5 divided by 2 is 2, with another remainder of 1, so that will go under the radical. For C, 4 divided by 2 is 2. So all of this comes outside the radical, and I ran out of room. This will all be multiplied by, we had this 3 that didn't have a pair, and this A and B that didn't have a pair. So in simplified form, we would have 4ab squared c squared times the square root of 3ab. So let's think about organizing ourselves a little bit differently on this one, again, in case the factor tree method didn't make sense for you. When you've got a radical times a radical, if it has the same root, you can go ahead and multiply them together under one radical. So 12 times 6 gives me 72. A, remember when we multiply powers, we add the exponents, so that'll be a to the 9th. So what we're going to do here is look for perfect cube factors of 72. And 8 is a perfect cube. So I can think about taking the cube root of 8, which is 2. 9 divided by 3 is 3, so those will come out of the radical. The 9, and I need my cube root there as well, will stay under the radical. So we have 2a cubed times the cube root of 9.